And uh, yeah, oh, we're recording. Um, but yeah, that's kind of where I am. I used to work at Yelp as well, doing similar things in the ML in the integrity space. But I've done everything. I've changed jobs numerous times in my careers and had uh, 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 a lot of different things. I'll open the floor. You guys can ask me anything. If not, I have some sample questions. I'll if we need to fill time, and then we can start discussion topics from there. Any questions? um, Anybody have? What's up? Oh, there's someone in the chat. I don't think I could see. I need to dial in from my computer to see the chat, I think.
Do you want me to read it out for you?
Yeah, if you could for now.
Oh, sorry. What advice would you give to your college self, knowing what you know now?
Recording in progress.
Oops. Okay. Ooh, I need it. Okay. What would I tell myself back then? Okay, so I think this is a more interesting question because of the kind of the industry right now. So back then, a long time ago, when I was graduating from Berkeley, there was this huge wave of outsourcing. A lot of like what we thought was going to be programming jobs would get outsourced to India. And I was super scared. I was super scared because I was like, what if I come out in that industry and all the jobs go away? And back then it wasn't as lucrative as it is now. But back then I just remember that fear of like the job might not be there. And then, for example, like I had a backup plan to go to med school and all that great stuff just in case it didn't happen. So I just, knowing what I know now, I think that I tell myself that like if you're really interested and this is what you're doing, you'll probably figure out some way to make it work. Some of it will be a lot of sacrifice, meaning that like you might not have your dream job out of college, or you might have to kind of work your way up there or figure out like where the hot spots are to do. But if you really like it and you want to do it, I think the jobs are always going to be there. It's just you might not get where you want it to be in a very direct path or a very efficient path. Um, uh, did that make sense? Well, okay. Any other questions? I see that I'm reading the chat as well, so I can. What advice would you give to someone who's interviewing for an ML or data science position? Okay. Yeah, this is an easy one. So for the ML, right? Like the biggest advice I think you should get is that whatever you prepare for, try to interview, but try to get as much understanding of what that process entails beforehand so that you can spend the time that has the most return on investment. For example, like ML is and data science is kind of new. So a lot of companies try their own different interview things. Like a lot of them, like for example, here at Meta, when I interviewed here, it was like literally 75% coding. So a lot of like leak code type of stuff. And 25% of like ML type system design. But the one thing is that like the coding will stay constant depending on what level you interview at, but the 25% changes broadly. So I knew that, like, for example, since I was a more senior person, they wouldn't ask me how to like fact checks. But like for maybe like a more junior engineer, they might ask you like, what is deep learning, or what is gradient descent. So those kinds of questions don't come to a senior engineer, but having gone through that process, I knew exactly what was going to be there. That fact checking portion wasn't going to be there. And then I allocated my time correctly, which is that I spent a ton of time on like leak code type stuff, and then 25% of my time on like ML system design and all that great stuff. But all companies do it differently. So like big companies, you have a lot of like understanding of what that interview is going to be. Smaller companies might be a little bit more flexible on what they want to ask. So like if I was doing a startup where I had no like idea of like what they're going to do or what they're going to ask, I would just go back to basics and assume that like they could ask anything and review the stuff that I might be not so fresh on. So I would maybe review my fundamentals in those types of situations. But a lot of times you can like go on Blind or other forums to see like what that interview consists for your level, or get it out of the recruiter to kind of really prepare and really target your time correctly. Okay, so next question, based on current trends, a lot of CS majors worry about the future job market, like I did with India. Having insider knowledge, do you think the computer science jobs will continue to grow or shrink? I think that the 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 I think the top end of the spectrum is changing, but I think the computer science market is vastly big than it's bigger than what you think it is. So for example, like there are computer jobs for like institutions that you wouldn't expect to be there computer science jobs for. For example, there's computer science jobs at like one of the companies I used to work for Verizon. One of my colleagues went from Verizon to Stanford. Stanford has computer science jobs. I think that low end has always been very hard to attract talent, or the mid end is very hard to attract talent. And that's where I see a lot of like computer science majors start funneling back into, rather than like trying to strike it rich in some of the top end places. So I think a lot of programming jobs will go back to institutions that are more local, more localized, but not as maybe glamorous as something like Meta. As well as I think there will be like you've probably seen it, there'll be an increasing focus on AI and ML, where that is where like people see the biggest growth. From like just a high level perspective, right? You have your tools that you've had in software for ages, like back end, like front end, all that stuff. Recently, AI came out, and people have been using back end and front end and what all those logical type of stuff to solve the existing set of problems. But they always had like these other set of problems that could never be solved, and now industry is trying to move in and say that like maybe we can use this new thing that we never had before to kind of solve those problems. I think that's where the market is. That's where like people are trying to like take open source models, or take things that other providers provide them, like ChatGPT or whatnot, to integrate into problems that they weren't able to tackle in the past. And that's where I think the job market is going to head. Okay. Let's see. Next question is, how do I feel about AI in terms of programming? So as an ML engineer, I think that like it is scary, but it is like everyone has it. I think it's there regardless of if you want to jump on the bandwagon or not. So I use large language models in my own work when like I need to figure things out. So just as I used to use Google search in the past, I now use a large language model to help me speed up my work. A lot of that is that what I used to write, that first part of the initial writing process, like writing code process, is much, much easier. So if I want to like, I don't know, if I want to do like a pie chart in pandas, which I've written a million times and forgotten a million times, before I would Google search it. Now I just ask the large language model to write me like a sample code, and then I take my programming skills and just replace it where it needs to do to fit it. It gets me 80% there, and then I take it 20% rest. The hard part is that it is untrustworthy as heck. It will give me function calls that don't exist. It will tell me that there's a data source that doesn't exist. It will pretend stuff. It's up to me and my knowledge to make it there. But I think now that it's there and now that everyone's using it, right? The expectation is that like you should not be stuck too often. You should be a little bit faster, and that you don't have to spend that part of your brain cycle, that the hard part to just get started. You're going to get started a lot. You're going to be able to get a jump start on certain problems, certain areas of the that you need to do. So in some sense, it's also made programmers more courageous, right? So like, let's say that you needed to pick up a new framework, or you wanted to do web development. I hate web development. I'm a backend engineer or ML engineer, but if you needed to make like a web app, you have someone that could help you get started, that you could create something with really, really quickly. I think that's where the change in paradigm shift is. In the past, folks used to ask me to make a website. I think I'm not a front end engineer. I am not doing that. I don't think that flies anymore. You have those tools a little bit better now, and I think that's going to change in our industry. Next question. How do I stay up with the latest developments in the field, and what resources would you recommend? So I think when you go out in industry, there's two kinds of folks. One, there's the same kind of folk that basically their lifeblood is programming. Their lifeblood is like, it is interesting to them, and they will spend their free time on them. They're like the 10%. And then the rest of the 90% are interested, they're passionate, but they also want to have lives. Those for the 10%, it's easy for them to find things that they're passionate about, and they'll explore that with work or without work. But for the rest of the 90%, we typically read what is interesting to us and more relevant to what we do. So, for example, like before I was at Meta and Yelp, I did nothing in the integrity space. I didn't really read much on security or ML techniques or anything. I did a lot of like, deep learning is super cool. I want to make GANs. I want to make really cool deep learning models and try the latest techniques and do that. Once I got into the field I realized that like knowing all that stuff doesn't really help me in my line of work. So I spend a lot of my time researching it and thinking about like, is this applicable to what I do? And then I'll explore it a bit more. So for most folks, I don't think that's really an issue. You really, like, once you get into industry, you kind of figure out like what your senior folks are reading, what other folks around you are reading, and what they're learning about, and what they're utilizing to make their product better. And you sort of explore the space around that a bit more. How important are personal school projects to a CS student? They're important if you have nothing else. Once you get into industry and once you have job experience, that's the most important things. They want you to be. So companies hire people to be able to solve their problems. Oftentimes the personal projects and the school projects don't really demonstrate that, right? So for example, a personal project might not have you working on teams. When you get into industry, all you do is work on teams. People are going to rely on you, you're going to rely on back. there's this whole aspect of being able to communicate well, being able to explain yourself, being able for folks to trust you and trust that you're able to deliver. That's sometimes not captured in a personal project or a school project. So that I think is changes. So like after you get a couple years of experience, you'll start highlighting that. You'll start saying that like, hey, like this project I worked by myself that's super cool that had no other involvement isn't really what a future employer might care about. So you'll stop putting that on your resume and whatnot. So that's kind of the flip side of it, right? It goes back to what I said, how I felt in school, where CS felt lonely when I was in school because you're just in your room coding. Whereas in industry, it's not like that anymore. You're working with other people. You have to talk to other people, hopefully make some jokes here or there. But you have to figure out how to work as a part of a larger organization. How do you limit scope on the personal projects? A lot of the things I want to work on would either require more compute or more knowledge than I currently have. Okay, the compute thing is kind of a misnomer. The as well as the knowledge thing. So this is a skill you'll develop over time. The ability to scope projects is one of the hardest things to learn, but also one of the most important things to learn, right? So if you have to kind of figure out like what can you actually achieve, like can you actually pick up something, can you learn about something, and then if you're blocked on something, you have to figure out like what's a reasonable substitute to be unblocked. So at least for like compute and whatnot, right? Like the thing I would say as an ML engineer is that like, are there smaller models that won't perform as well, but would get you 90% there? And you could show that effort. Can you do you really need that compute? How do you limit the size of that compute? Is the other question, right? So one of the things that you learn as an ML engineer is like, how do you best invest your time? Uh, Training a model can take weeks. I tell a lot of junior ML engineers that like, how long is it going to take for an iteration cycle? Is that acceptable? Like, if you're going to wait like 2 months before you learn that your model is working, that is unacceptable because those 2 months came in and you made a silly mistake or the data set was bad or whatnot. So usually when we talk about compute, we have to kind of answer like, is the trade-off worth it? Is working that with bigger model worth it? Usually like oftentimes I don't think so, but we want to get some indicator or something to learn something without really having long iteration times or being blocked on things of that nature. Do I have any good resources for learning machine learning outside of school? I don't. Occasionally, I read a lot of Hacker News, and I occasionally come through a lot of ML side projects that people do. The best ones I would recommend are doing the ones that people have like GitHub repos for and trying to reproduce that. Usually you learn by creating. So I would just put myself in the shoes and just try to create what they create and then try to learn what I need to learn through that. The harder things are sometimes like the harder things to do are to step back from a problem and kind of work through it. When you're given like a complete answer, it's kind of hard to like just get the issues or get the trade-offs that they made because the trade-offs are already there. And sometimes it's just worthwhile to try to do it yourself, and if you're stuck, figure out what they did to do it to bypass that. When you get into industry, one of the biggest things you realize is that like people just read a ton of code. Half your job is just reading other people's code. Oftentimes something's broken, you have to read someone else's code to figure out how to unbreak it. Very similar to this, where like when you see other people's code, where you're like, you have to figure out like, oh, that's how they did this, or how these little mechanisms work. So there's a lot of hacking in it, and then from that hacking, creating your own products from it. Will AI be used to replace programming jobs, or replace some programming jobs, or used to be search up answers like Google? I don't know if it will be, it depends how you say replace, right? So at least for the large language models, they hallucinate like crazy. They give wrong answers like crazy. But I think that what used to be like a 5-person project will now be a 3-person project, because you're giving so much efficiency to being able to start up, right, get 80% there. But programming jobs will not go away. There will be bugs. Like even the most perfect programmers will write bugs. There will be bugs that are introduced by edge cases, and AI is not going to go in and solve that. The the way you should think about AI is that it is, a lot of it is the accumulation of knowledge that is in a very handy, convenient place. But sometimes that knowledge has yet to be discovered. So like, for example, if a site breaks, if something breaks, oftentimes it's because it hit a case, an edge case that was not considered before. That accumulated knowledge probably doesn't have that edge case. It takes a human brain to kind of solve that. So I don't think it'll be replaced, but I think that there's definitely efficiencies there that kind of contract the job market a bit. You wanted to learn more about my work at Meta and Yelp. So I have all been in the adversarial space for a while. So at Yelp, I was on the traffic quality team. We basically try to detect botnets that were entering the system, and then screwing up various places in our advertising chain. So a lot of people will look at their stats and say that like, oh my God, I got 100,000 views on my page, and then 90% of those views are from a botnet. So we try to kind of weed that out for our downstream teams, and there's also advertising that we also weed out. We don't want to charge customers for eyeballs and on ads that weren't what we call organic, meaning coming from a real person. So I developed a lot of novel techniques to do that using ML. I do similar things at Meta. I think I'm less privileged to talk about that, other than like we tackle adversarial third-party apps like Cambridge Analytica, and try to use ML techniques to do that. What subjects in ML are more popular here? Yeah, so this is easy. You should know this. It's all Gen AI these days. That is where the new hope and promise is. Almost every big company is trying to use this to solve a problem that was unsolvable before. A lot of it is tough. There's a lot of being deep in the data to kind of figure out it. This kind of the best way I think about it is that we recently discovered aliens, and now we're just have to figure out how to talk to these aliens that we recently discovered, because they're everywhere. So that's kind of the work of ML right now, which is trying to figure out how to talk to aliens. And just as a programmer, your job will be using a large language model. I'm pretty sure at this point that's where the industry is headed, for you to get the efficiencies that you need. What are your top 3 tips and advice for students looking for internships, or new grads looking for full-time? I think the biggest tip I already said, which is figure out what you're capable of and whatnot, and then really target your time investment to do the best on your interviews. there's this thing called the interview pipeline. So, the typical process is a recruiter reaches out to you, or you reach out, you get a call back from a resume submission or whatnot, and you're in the interview pipeline, quote unquote. That means that like there's certain phases of that interview pipeline that you need to be really good at, right? So if you like talk to a recruiter and she never moves you on to like a coding challenge or talking to a manager, you need to get better at talking to that recruiter. If you don't get a recruiter call or after submitting a million resumes, right? Maybe you need to work on getting your resume really, really polished. So those are the usual things that I usually tell folks that depending on where you are at the interview pipeline, figure out which place gives you the most bang for your buck, right? So if you don't make it past the recruiter stage, maybe you shouldn't spend so much time on leak code and passing interview rounds or whatnot. But if you get past that really easily and you just keep on failing interview rounds of leak code, that's where you should focus your time, even if it's painful. So those are the big kind of tips of like, be self-aware, and be very critical of where you're spending your time. You're going to get paid a lot if you get a job as a programmer. So if you think about how much your time is worth, then make sure you're spending it in the right places. How was the interview process at Meta as a whole? How long did I spend grinding leak code? I don't remember. The interview process was great at Meta, but it was a long process. They have very changing business conditions. A lot of times, like depending on if the stock takes a nosedive, they will freeze your process, or if it goes up and they need to hit hiring counts, they will speed up your process a ton. If they're very reactive. So when I got an offer from Google as well, they wanted to close the deal as quick as possible. So they made it very hard for me to consider Google when I got it. I don't know how long I spent grinding leak code. I just knew that like I could do any medium problem blind, like like if I never saw it before, I could do it in like 30 minutes. I think that was my bar, and I could do a hard problem. Half of hard problems that I saw, I could do in an hour. That's when I started. That's when I kind of realized that I was at a sustained acceptable level for where I wanted to be. Aliens. Oh, yeah, aliens. So like large language models are basically like talking to an alien, right? So a lot of like ML is these days are just trying to figure out how to talk to a large language model to do the things that you want. So like one of the things that we do in ML that we work on is like, if I need to ask it to solve this problem, how do I give it enough context to solve that problem? So like, I don't know, let's make up an example of like figuring out if somebody's a bad guy, right? So you would say that like, hey, large language model or whatever, these are previous examples of bad guys. Here's the description, blah, blah, blah. Here's a current description of this guy we want you to classify. Is he a bad guy? It's basically that. Like you have to give the alien context. You have to train it. You have to know how to talk to it, what makes sense. And then you also have to know like, maybe we need to go back to the innards of the alien and say that like, give me a different alien that is better at doing what I need it to do. If I had a choice between schools like Harvard and Georgia Tech for a master's in computer science, would I have a preference? I don't know either of those schools in terms of their pedigree for computer science. In general, if you don't need a master's, I would say I would rather not advise you to do a master's. If you don't need it. So if you have a high GPA and you can get a call back from a recruiter and you can get into the interview pipeline, I don't recommend doing a master's. But if you do it, make sure you have a really high GPA. I would do a little bit more research on certain funnels that they might have into companies that are attractive to you. So, for example, like I would see if there's a lot of Harvard students that get into the companies you wanted to go to, or Georgia Tech students that get into the companies you want to go to, and see if they have like relationships with that school. Do they go to the career fairs? How the career fairs are like for that, to make that decision. But I don't have context on much of that. I haven't really dealt with that pipeline. Oh, yeah. So I mentioned that I started out as in electrical engineering and then switched to more of a software focus. Um, let's see. Electrical engineering was very different from software. But to be honest, I was really chasing what I thought was interesting uh, and how to say it, very trendy at the time. So when I graduated, everyone was very scared of computer science jobs going away. But that was during the silicon boom. Intel was really big back then. Uh, I wish I knew Nvidia would be really big, but they were also players. And then AMD was really big. So those look exciting to get into that industry. But as soon as I got into electrical engineering, I think I was at I forgot what company, doing like microchip design. That was when the mobile boom came, and mobile was where it needed to be. So like phones and whatnot. So that became really interesting, really like sexy. So like I went back for my master's and did it on wireless theory, cellular theory, and then I joined Verizon after that because that is the like mobile place. But like going through all that, I think I still like really I was drawn to programming. Like I really enjoy programming. I really enjoy data. So getting closer to that made me really happy. So that's where I came back and started learning AI techniques and machine learning on after work and really explored that. But it was really just like what you guys are going to do all your career. What is the exciting thing? What is getting a lot of investment? What is the place where a lot of innovation is happening? And then trying to explore that and trying to be at that place and be prepared for that. I think that's just the way that the industry is kind of working. There are, as you go through life, as you have other friends, you'll realize that this career is kind of different now than it has been. Like I have friends that are teachers. They don't plan on ever learning anything new ever again. Their industry doesn't change. I have friends that are doctors. Like after they get out of school, like they're planning that life for the rest of their lives. I don't think our industry is like that. It goes through a lot of flux. It goes through a lot of changes. Like new things get discovered, and everyone's racing to make products out of it. Racing to get go through that. Um, but it's also exciting at the same time. It's very cool. Like I was doing a workout in VR this morning, so like I never thought that would happen, but I work for the company that makes that and makes it happen. So it's cool to be part of that, but it's also like scary in that like you're always constantly learning. You're always asked to change. You're always asked to improve. There's always something to learn. You can't rest on your feet because like the industry changes so much. What does my day-to-day routine look like? Um, it changes, it varies a lot. So we have very different cycles. So usually for software engineers, there's like this planning cycle, there's an execution cycle, and then it just goes back and forth. So um, we work in halves over at Meta. So every half we start planning. So we plan to work, what are we going to do the next half? So we start thinking about like, here's a project we can do. Here's many, how to resource it. And then you go and say, like, you work together with your team leads to say that, like, hey, manager, do you think it's worthwhile for me to work on that, or I can get other teammates to help me out with that? Here's the impact that it will deliver. And then maybe that gets us from like the end of one half to the beginning of another half, and then you just execute. You put down milestones, you put down things, and then you just start working. And then you just execute, and then you try to hit your milestones, and then before you know it, the half is over, and you just repeat that cycle, planning for the next half or whatnot. Other companies I've worked for work on software releases, so their cycle is not strictly a half. Their cycle is like, hey, every time there's a major release, we plan for it, and then like we plan what we're going to put in that release, and then we execute, and right before the release is like the worst time because you're working crazy hours to make like the release, everything in the release, doing testing, dealing with bugs, all that great stuff. So usually it's those two cycles of planning and then execution that determine what your day-to-day is like. So if you're in execution, hopefully you're not in a lot of meetings, you're coding, you're figuring things out. And then when you're in the planning phase, you have a ton of meetings, making sure that you get enough stakeholders to work on your project, or you know what you need to do, or you find a project to work on that needs help. So you start planning where your work is going to be for the next half, or the next cycle. I think that's it. Does anyone have any other questions? I did have some C questions. So things that I think are interesting are the differences between a startup and a big company. What startups you should join, what should be your expectations at a startup? Or we could talk about pay. If you want to talk about pay as well, I'm open to those kinds of conversations. Anybody want to submit any of those, any of those questions? Put it in the chat and tackle one of them. Okay. Do I ever get bored working or learning? I love to learn. I hate meetings. I think the reason why I'm a programmer, the reason after all this I'm a programmer, I used to be a manager. I used to manage people, and I kind of stopped and went back to being an individual, and what we call an IC. I think one of the coolest things about programming is that we get, not a lot, we get certain times where just focus, like you get into the focus mode. So my favorite days are when like I have this really hard data question or data thing, and I just put on my headphones and I just try to solve it all day. And then like I look at my clock, I'm like, oh shit, it's 5 p.m. and I need to go pick up my daughter or something like that. Those are the best days because I'm just in the zone. No one's interrupting me. It's like this super, like, it's like play. You're just playing all day. Getting things to work. Like at the beginning, a model cannot work or something just looks completely off. Those are my best days. I do a lot of shit to get to those best days. Like I have to go through planning cycles. I have to like do meetings where like people gain trust on me. But on those days when I'm just like alone coding or whatnot, and figuring things out and making something cool or solving a really hard problem and just listening to music all day, those are the best days. So that's what I really enjoy. And I learned that after a while that I really enjoy and get paid for. That's why I do it. And that's why I stopped being a manager, because you don't have many of those days as a manager. You have other joys, but in my opinion, that's the one that I really love. So if I could have those days, I would never get bored. I love to learn. Learning's great. I usually learn with my headphones on music. That's usually those days. So I think that's the best part of the job. A startup or a large company as a new grad. Okay. My opinion is that a startup is stressful as hell. If you've ever joined a startup, it's stressful as hell. But that stress will build so many strong muscles for you. But if you can handle it, I've seen a lot of people burn out at startups. You also deal with like a ton of shit that uh, that uh, that normal people at a big company will never deal with. So like I've had crazy stories with friends who went to startups where like they stopped paying them and they had to like figure out that like they were going to go under. You would never have those kinds of problems at a big company. So like you don't have to worry about that. But the flip side of a startup is that like everything's broken and you have to learn a lot of different things all the time. And you grow from that experience. Meaning that like at a big company, you could say that like I don't do front end work. At a startup, there's no one else to do that front end work, and sometimes you have to pick it up and you have to learn it and do it, whatever it takes to get the job done, because there is no one else. So that's kind of the flip side of a startup versus a big company. Startups also have like it's a lotto ticket. You can win big. I've known a few friends that like were at the right place at the right time and then they got IPO and made a ton of money. So that's the other allure of a startup where like you can actually like get rich enough that you won't work for the rest of your life. At a big company, that's a little bit more rare, but it's more like even queue, meaning that like you will find a good job to support yourself and whatnot. You will have space where it's not too crazy to have those good days. And you won't be asked to do so many crazy things or things that might be outside of your role of responsibility. But there's a lot of people that say that like it being challenged with that was great for them to grow into a person, to a better engineer, uh, to a more apt one that they could do any challenge. What does my salary history look like from the time from my first job to now? Oh, this is a good question. I think when I graduate college, I'm gonna maybe for the sake of comparison, adjust it for inflation. So in today's numbers for everything, right? When I graduated college, probably I was making around 60,000, 70,000. Not so much. I actually like that switch into electrical engineering. Oof, that did not do wonders. Um, and then maybe through different companies, I started hitting 80, 90. I didn't work at the best companies for a long time. So Verizon's not very like high paying company, for example. When I became a manager, I was making like 120, I think. In today's numbers, not much. And that's when like the AI boom kind of came in and and I came back and transitioned to being an ML engineer. Um, at Verizon, I did a lot of roles. Some of it was I was also a data scientist after being a manager. So I left Verizon making about 130, 140-ish. And then when I started at Yelp as an ML engineer, I was making like 230, 210, 230-ish. And then when I started at Meta, I was around 400. Luckily, the price stock went up a bit, so I'm still making about 500-ish, I guess. But like it's all stock dependent, and it's also like very much grant cycle. But yeah, that's a bit of the job history. The one thing I will say is that like the stress levels and demands of the job have gone way up. I think about the days when I didn't make as much and how less stressed and more free I feel. Um, whereas at Meta, like you're always expected to perform. There is no allegiance. Let's say that they're always asking what you have done and judging you, and if you don't deliver, you might get laid off or separated from the company involuntarily. So it's a very demanding place, similar to like other workplaces. So like at the other companies, I could have stayed making what I made for a long time, but also had like no fear of ever being laid off or let go. Um, so that's the trade-off.
Oh, hey Danny, sorry to interrupt. I think we have room for around like one or two more questions because in about 5 minutes, we'll probably be kicked out of the classroom because of another class coming in. So I think these
Cool.
last two questions will be good.
Sounds good. I think the last. Okay, for ML engineers, higher than a bachelor is needed. That's a quick one. No, if you don't plan on doing research. So if you do research, you need a PhD. So if you want to invent the next deep learning thing, then definitely get a PhD, because usually that's the folks that are into that pipeline. Common mistakes new engineers make when starting their careers. This is probably a pretty good one to answer. The best mistakes, I mean, the best thing to do to limit your mistakes is talk to people, and figure out where you should invest your time. Figure out and be very critical about where you're spending your time and what your weaknesses are. If you're, I see new folks like not work on communication skills and not work on working with others, and basically they go down rabbit holes and waste a ton of their time when they could have been like talking to someone and someone said, oh, don't do that, or that's bad. And then they would be able to not spend a ton of time or not waste a ton of time on something that was solved before or could be solved by talking to someone. But just keep on talking to other folks, be critical, and keep on figuring out where you need to invest your time. All right, well, I think that's it. Hopefully that was useful. Yeah, good luck. And if you're ever in Meta, look me up.
All right, thank you so much.
All right, have a great day, everyone.